Good morning. Welcome to episode number 50 of the Zoomtown experiment. Just a couple more episodes and we're going to hit a total of a full year's worth of the episodes. It's been a long road to get here, but we're getting down to that final stretch. As I've mentioned in the past few videos, it's getting harder and harder for me to stay ahead of everything. Everything is kind of coalescing right now with the last details that all have to be put together to start running the actual experiments. The three items that are an area of focus for this particular video has to do with random time, random place, and band positions. Random times means that a Zoomie would be dispatched at some random interval. Each time it gets to a destination, it will be assigned a random time duration to wait, and then when that time duration expires, it will get dispatched to a new location. Random destinations means that anytime it's wherever it is, if its time is expired and it's ready to go, we will pick a random available destination for it to travel to. Finally, not all destinations are available. There are certain maneuvers that the Zoomie isn't going to be able to do. And I need to ban those positions, start and end points, so that it doesn't or isn't forced into performing a maneuver that it's not capable of. That'll make more sense here in a few minutes. Along the way, I had to change some of the data structures that have been in the scheduler so far. So you'll see one big change involved with that. But being that that was just a list, it's trivial in the bigger picture of things. Another one of the lists, pre-existing lists, also had to be modified slightly as well. Now, following up, after we get this random place and time capability implemented, I also will be following it up with implementing the shortest path algorithm, the Dijkstra algorithm in particular. That was actually in the very beginning of this whole project when I first conceived it. As time went on, I took it out because I thought it was flawed. Luckily, one of our viewers, Tomek, reminded me or educated me that my thinking was wrong, and so we're reincorporating it, and I'll be talking about that in the next video. So let's first take the one thing that is probably most confusing for everybody, and that's that band places. Now, if we go to our overhead view of the city here, let's say I'm in this parking spot right here. Now, very easily, I can have it go from this one to this one, or this one, or this one. Doesn't matter. But what I can't do is back out of this driveway and then turn left and go straight across the street. So going from here to here is banned. So it's banned from here and here, here and here, here and here, and here and here. All other destinations do not suffer from that directly across the street alignment. I could put in more code for it, but rather than mucky it up with more of that, I just ban it so that it can't go from one to the other and let it go to some other location. So that's what I'm talking about, a banned destination. At this point, we're in the code, and this isn't the full scheduler code. This is only a section of code that covers the functionality we need right now, and that is random time, random destination, and banning any operation or any movements from one location to a banned location. So consider this to be part of our main program, the scheduler. Before it starts, we'll preset the Zoomie park times, meaning any Zoomie that's in play would be assigned a random time interval so that it can get the process going for an experiment. And we've just got a counter here, and that's just to limit the runtime of the experiment and our test code here. But what we're going to do in our main loop is assign new destination, call the function, assign new destinations for all zoomies. Meaning every time this runs, and ideally it really has no purpose or need to run more frequently than once per second or once every 2 seconds. The resolution isn't that fine or needed, so I'll probably restrict it for running all the time, meaning every single loop cycle, which right now I think we figured out was about 15 times per second, maybe 10, something like that. But we will run that constantly. So assign new destinations for all zoomies is the function. Then I'm just going to increment this counter because we're going to limit it to 25 runs. We're going to sleep for a couple of seconds in between, and that part will be, so to speak, real time. I've shortened it up a little bit to help make it run a little faster in our test code. And then finally, I'll just print out what current line or index that we're running right now. So let's look at the preset the zoomie park times. That's this function right here. We're working with a list, destination coordinates, and I'll go into that here in a minute. But all this is going to do is go through all those destinations, 32 of them, and if it's currently not equal to empty, meaning some zoomie's already in it, we're going to generate a wait time of a random amount of time, and currently it's set at between 3 and 6 seconds. In the final version in the scheduler, that'll be bumped up to probably a minimum of 30 to 45 seconds and a maximum of maybe 90 to 120 seconds. That will, that frequency, not so much here because this is startup code, but in another area of the code where I assign these random times, that will define how much traffic is all simultaneously moving around and how congested everything gets. But we'll generate that random integer for our time, and we'll write that into our list, destination coordinates, into the 5th element, well, technically the 6th element, and we'll just round, take the current time rounded, and we'll add in the wait time, and that would establish the release time when the zoomie can then be freed up to go be sent to someplace else. And then I just print that out so I can keep track of it. Now let's take a look at destination coordinates. We've already looked at that superficially when we were going over some of the other code. I don't know if I really went into detail. But destination coordinates are the locations of each driveway. Each one of those has a destination number, 1 through 32, and that is the index into the list. And then it has that originally just contained the X and Y coordinate for each destination. And that would be right here, the 0, 0, the very first indexed position, the very first list item. That one is a null item. We're not utilizing it. We're utilizing 1 all the way through 32. It makes it a little easier to manage, even though I'm wasting that precious little memory location. But each destination has its X and Y coordinate currently in the scheduler software. Now we're going to have a field added to that, or element, if you will, that will contain the name of the zoomie that's currently residing in that driveway. If there isn't anybody in the driveway, it is marked as empty, meaning available. Somebody can be dispatched to that location. Then we are going to, let's see, I want to get this straight. We've got the is occupied field here, and then band destination 1 and band destination 2. We just talked about that. 2 driveways that are 180 degrees apart, or one directly behind the other. We need to band those, and that would be these index numbers right here that we would band based on this index number for each of these lines here. And those that are banned are 5 to 9, 6 to 10, 7 to 11, and 8 to 12. And those are the ones I pointed out on the graphic earlier. And then finally, number 5, as we just talked about in our preset section, is the current time at which the Zumi was parked or experiment started. Now that would be updated every time a Zumi gets parked. It would be assigned the current time plus some random period of time between some set range. And then that is our flag. When real time catches up to that time, it's time to dispatch that Zumi. And that's what all of this data is here. Now we'll go all the way back down. All right, got some other test code in there. Now we're into the loop. We've done that, and we've talked about the destination coordinates. Now we're going to go into this function here, and that is assign new destinations for all Zumis. We will go right to here. This function scans all destinations to see if a Zumi is in a driveway. It then checks to see if its release time, the time that's in field number 5, technically 6, has been exceeded. If it has, it then checks the location of the Zumi to be sure it is in the driveway and not in transit to the, bear with me, driveway. Well, what's that? How does that make sense? Well, I might when I dispatch a Zumi from one location to another, I immediately assign the Zumi to that destination so that it doesn't get assigned by another Zumi. Remember, this is all happening sequentially, so it could get, actually, multiples could be assigned to that destination if they all stacked up. So I got to wait until I physically get in that driveway before I can reassign that particular Zumi to another location, even if his time has expired. If all the tests pass this phase, then it finds a new destination for the Zumi to travel to. This repeats through all the destinations, meaning this loop will check all 32 destinations looking for an empty spot or a not empty spot, and then assigning someone to go there if someone's available. So the function starts out, we record the current time, we then step through or iterate through the entire range of all destinations, 1 through 32. If a destination is not equal to empty, meaning it's got a Zumi in it, and if the current time is greater than the release time, which is stored in entity number 5, then we will get the Zumi number that is in this current destination. And that would be what was stored here in element number 2. Now we gotta, because we're using the name of it, let me get back up there, we're using the name of it and not the index number of it, which is in its list. We run a function. I gotta find myself again here, bear with me. We'll find the index number of that Zumi with this function, find index of Zumi ID. So we'll pass it the Zumi number, which is this guy. And with this function here, it's passed in the Zumi number. It could be a number or a letter. This would be the 1, 3, 5, 7, 8, A, C, etc. And that's how I get just the second character. I don't care about the first character. And then I look through our range, through our list of all the Zumis. And when I find the 2-letter ID, such as Z8, I will then, if that matches that, meaning this, we've found it, and I return the index number of that particular Zumi. It's just a way of matching index location with the name of a particular Zumi. Dictionary would have been really good for that, even probably better, but I need to add more elements to this as well. So we found that particular Zumi ID. Right here. Then we're going to compare the locations. Remember earlier I said when a Zumi is dispatched, its ID will be placed in the destination, but I can't move this guy until he actually gets there. And if it gets caught up in traffic, it might not get there in time before the release time expires. So to do that, we will get the coordinate of the destination, the current coordinate of the Zumi. We will do a little bit of simple math on it and calculate the distance between the two. And if that distance is less than a half inch, I can safely assume it is in the driveway. And then I will find a place for it to go, meaning I'm ready to dispatch it. And that function is right here. Now we're going to have to go through and iterate through the whole list of destinations and find out who's available and who is not banned. So let's read through my commentary here. Calling function determines if a Zumi needs to be moved based on the current time and the release time. It will randomly select the destination between 1 and 32. It'll scan the destination list for all Zumis in a destination, test if the possible destination is on band list number 1 or band list number 2, in which case it can't send anybody there. So then it'll go through the loop again. If the test passes, it will assign the Zumi to the new destination and generate a random time for it to stay at that destination. So it gets assigned that next interval before it even gets there. So let's look at the code. While true, endless loop. Often dangerous in situations like this. But we're going to first grab a possible destination by generating a random number between 1 and 32. If the destination coordinates of the one right here that we're looking at, possible destination, if it's empty, then it becomes possible. If that destination is not in the current band list, meaning it's not equal to possible destination, and if it's not equal to the second possible band destination, then we're good to go. Then what we're going to do with line number 89 here, we will set the possible destination with the current Zumi ID. So we'll update new destination with Zumi ID. I've got a note here. I've got to change this delay time when we get into the real code because it's currently only waiting between 3 and 7 seconds. And as mentioned before, that'll probably be in the range of 45 seconds to 2-3 minutes. So we would generate a random wait time. And at that possible destination, and element number 5, we'll update its new release time right here. And we will then change the destination coordinates of the current destination. We will change the ID that's in it to simply empty because it's now available again. And we will reset the release time to 0 because, frankly, there's nobody in it waiting to be released from that location. And for right now, I just print out that data, and then we break out of this continuous loop and move on through the rest of the code. Going from if that was not equal to a possible destination, right now I'm just printing out band location just so I could monitor that that was actually working. And that was band location number 2 test. And this would have been the else of band location number 1 test. And from that, we've completely got, let's get all the way back here to this point. We found a new place for the Zumi to go to, and then the whole list is continued through all the rest of the destinations, and this process repeats. It'll go through all 32 destinations. Everybody that could be dispatched is dispatched, and then we wait for this to be all called again from the main loop. Now let's go ahead and run this, and it'll put out the randomized data. And we'll let it run for a little bit here. This is what it did on the preset. Gave it random times to wait for each of the different zoomies. And we'll just let this run for the 25 times through the main loop. With that data output, I'm just going to scroll up through that all the way to the top here. Copy that, and I'm going to place it into an untitled document within Thonny. Makes it a little easier for me to scroll around and show you stuff and not get lost along the way. First time through the loop, nobody was ready to be dispatched. Second time through the loop, it moved Zoomie 8 from destination 12 to destination 15. Third time through the loop, 4 more zoomies, 1, 3, 6, and C, each got dispatched, 1 to 8, 4 to 1, 7 to 27, and 23 to 20. And this just keeps repeating over and over and over again. You'll notice sometimes only 1 zoomie gets dispatched, sometimes 2, sometimes 3, 4. It varies just depending on how the random data comes together. So what I've done is I've gone through, followed a few of these through from where they started, where they ended, and it all does appear to be fairly random. And I'm trusting that the Python routine is random, and it appears to be doing a pretty good job. I'm not overly concerned if it isn't going to repeat after 10,000 times or something. That isn't really a major worry for me. But this should give you a pretty good idea how I'm going to randomly dispatch to random locations and not allow the zoomie to go from one location to another that it isn't physically able to do based on the maneuvers it can make. So that'll really wrap up this particular topic for random time, random destination, and banned locations, and how we'll be going through this process many times per minute over in the Zoomtown experiment. Next video, I hope to be talking about the shortest path algorithm. I'm not going to go into the inner workings of how it works. In all truth, it's beyond my way of thinking, and there's plenty of other great videos on that. If I find some that I really like, I'll post links for those. But we'll be talking about just the shortest path and having it generate for our situation. It's not quite as straightforward as you can imagine, and I'll explain the way in which I manipulated that data to work to my advantage for creating our trip plans. So with that, I'm going to end this particular episode, and I look forward to seeing you in the next one. Thanks again for watching.